velocity, when I'm asking about the direction, velocity is more closely related to instantaneous displacement. Actually, let's back up here. Two types of velocity. There is average and instantaneous. The default, if I ask what's the velocity, I'm asking about instantaneous. If I want to ask for the average velocity, I'll have to use the word average in there. So average velocity actually is related to overall displacement. Instantaneous is related to instantaneous displacement. And this might just be a jumble of words. Hopefully a lot of this will be cleared up when you do the lab piece of it. So when I ask, is my velocity positive, negative, or zero, what I'm talking about is instantaneous velocity. In other words, am I moving in the positive direction or moving in the negative direction? So right now, my velocity is, and my velocity now? All right. Yes, Kimberly.
So the average velocity is the same as the overall displacement?
Divided by time.
What?
It's a displacement divided by time. So the average velocity is my overall displacement divided by time. So when we were doing when I was doing the race with Usain Bolt, our average velocity was 0 because what I was looking at is for the entire trip, he doesn't go anywhere. Matter of fact, if I had not run at all, I would have gotten nowhere faster. Okay, it's technically in less time, but. All right, any questions? Because we're about to do the plus minus 0 thing, except we've got 3 things now. Quick responses are preferred. Actually, since I'm on the preferred, quick correct responses are preferred. Hannah.
So the instantaneous velocity is equal to the displacement?
Instantaneous displacement divided by time. All right. Are we ready? I'm assuming the silence punctuated by someone whispering the word yes is good enough. All right, here we go. My position. Yeah, that was not supposed to throw people off there. Let's try that one again. Position. Thank you. Displacement. Again, my starting point right here. And the origin over there. All right. My velocity.
0.
All right. My velocity now.
Negative.
Negative. I'm moving in the negative direction. My position.
Negative.
Displacement.
Negative.
Velocity.
Positive.
Position.
Negative.
Displacement.
Negative.
Why is it negative? Because you're moving in the positive direction. You already walked over there.
My velocity was positive because I'm moving in the positive direction. My position is negative because I'm on the negative side of 0. And my displacement is negative because I'm on the negative side of my official starting point.
There it is.
All right. You good? All right. So it's over here. I'm going to try to move slowly. My velocity? Yes. My position? My displacement?
Negative.
Yeah, that's what I'm going for. Yes, Kimberly.
I'm still confused, like, I don't see anything with your.
Oh.
So, yeah.
We're going to be dealing, let's first give a context. We're going to be dealing with these terms for a while. These are important terms to use in physics. Being able to interpret your answer is critical. And so since it's a vector, direction matters. And in a one-dimensional problem, you could have a position that's positive, negative, or 0. There are really only those three choices. And as a hint, despite what some students have told me in the past, it can't be two of those at the same time. It's gotta be one of the three. So, position, if a position is positive, that just means you're on the positive side of wherever you decide zero is. And for this exercise, zero is right here, as I walk back and forth. So my position's positive, my position's zero, my position's negative. That's what we're doing right here. I guess you missed the very first part of when we did this. Displacement is where am I relative to where I started, overall displacement. And I officially labeled this as my starting point. So, off camera, but the international fans will just have to imagine. So here, my displacement is zero. My position's positive because I'm on the plus side of where zero is. And so here, I'm now on the positive side of my starting point. I'm now on the negative side of my starting point. Did I get close to what you were asking?
Yeah, kind of, because your position, like, the displacement is gonna be negative once you're off the starting point.
It's gonna be negative when I'm on the, I just said, let's make that way positive. I could just as easily make that way positive, but, so that way is positive. So whenever I'm on the negative side of my starting point. So whenever I'm on this side of the starting point, I have a negative displacement.
Even if you're still on the positive side, you're still on the positive side, right?
I'm on the positive side of zero, but the negative side of starting point. That,
Mhm.
all right, and then,
Yeah, because I was confused, like, because you said that was the positive side, but you're still on the positive side, so that's why, like, I was
Yeah.
confused on how it was negative.
yeah, I'm on the positive side of one reference, on the negative side of another reference. Yeah, and the last problem on the first test will be a problem more complicated than what I'm doing right now, but it's the same type of plus minus zero thing. For that, just because of the vocabulary that I want you to show that you understand, I will make the starting point and the origin different. However, oftentimes in physics, you make the starting point and the origin the exact same thing, because I can make the origin anywhere I want. Why not make it at the starting point? In which case, displacement and position often get used interchangeably at that point, which I think is a answer to one of the analysis questions on the lab. But yeah, I'm sure I was going to say anything after that. All right, are you at least good for now?
Yeah.
Okay. Any other questions? All right, so velocity depends on which way I'm moving. And now we get to the hard part. This is the one that messes most people up. The next vector term, acceleration. Cleverly, they decided to make the symbol an A, but the vector symbol would be. We can define it as, I guess, the time rate of change of velocity, which doesn't necessarily mean a whole lot, but it's basically, it's how the velocity changes divided by time. How much the velocity changes divided by time. So if I go from 20 meters per second to 40 meters per second in 5 seconds, what's my acceleration or average acceleration?
2.5? Oh, sorry.
34?
It would be 4 plus units.
4 meters per second squared.
Yes. So acceleration is change in velocity. Change, always, one of the few always in physics, change is always final minus initial. I take my final value minus my initial value, divide by the amount of time. Let's throw some units in there, meters per second, meters per second. So I get 20 meters per second in the numerator, divided by 5 seconds. The math piece of it right there, that's the part you pop into the calculator or do in your head. And then the units, I got meters per second, but having more than one fraction bar in the units is undesirable. And so that's actually meters per second squared. The same units for acceleration due to gravity. Questions to hear? All right, so I'm going from 20 to 40 meters per second. Notice that that's positive and that's positive. So I'm moving in the positive direction at 20 meters per second, and then I go 40 meters per second also in the positive direction. Have I sped up or slowed down? Yeah. Now let's change it. I'm going to go from negative 20 meters per second to negative 40 meters per second in 5 seconds. What is my average acceleration now? I think somebody just said it.
-4
With units?
meters per second squared.
Yep. Because my change is negative 40 minus negative 20 divided by 5, which is negative 20 divided by 5, or negative 4 meters per second squared. Did I speed up or slow down?
Slow down.
Oh, try that one again.
Would it be slowed down?
No, speeding up. You're covering 20 meters per second here, and you're covering 40 meters per second there. That's a lot fast. That's twice as fast even.
It was just the signs that's messing us up then.
Yeah. The sign is just telling us the direction we're moving in. So we're going 20 meters per second in the negative direction, and then we go 40 meters per second in the negative direction. We have sped up. What I'm hoping you will pull out of this is that positive acceleration doesn't always mean speeding up. Negative acceleration doesn't always mean slowing down. That's probably the biggest mistake students make. The sign of acceleration is a directional thing. Also notice that when I sped up in the negative direction, my acceleration was negative. When I sped up in the positive direction, my acceleration was positive. That will hold true. Hoping people have that written down by now. If speeding up, the acceleration and velocity have the same sign. If slowing down, acceleration and velocity, opposite signs. And just demonstrating it with that, I'm going negative 40 meters per second, and I slow down to negative 20 meters per second. Let's do a different number, negative 10 meters per second. So I'm traveling in the negative direction the entire time. I'm going to cruising at 40 meters per second, and then I'm down to 10 meters per second. I'm traveling a quarter at the speed that I had before. And let's say I do it in 5 seconds, just to make the math nicer. My acceleration, negative 10 minus negative 40 divided by 5, which is 30 divided by 5, which is 6 meters per second. My acceleration's positive, but I slowed down. My velocity's negative, my acceleration's positive. They're sort of fighting against each other. Questions to here? I'm about to talk about a different way of looking at the exact same thing. All right. Now 110 has an advantage of the fact that we've already talked about forces. Unlike the traditional physics textbook, it doesn't get to forces quite yet. The total force acting on a person and the direction of, try that again. Total force acting on an object is in the exact same direction as the acceleration. Force creates acceleration. This will be summed together in chapter 4 with the formula F equals ma. Only two vectors in it. Those vectors have to be in the same direction. So if I'm traveling in the negative direction and I slow down, there's got to be something sort of pushing to get opposite the way I'm going. If you run at a wall and you slam into a wall, there's definitely a force, that normal force from the wall is acting against the direction you're moving. It'll slow you down. So when the force is against the direction of movement, so you're moving this way and a force pushes you back or pulls you back, you will slow down. If you're moving, flashback always to probably 7th or 8th grade, walking across the gym, not fast enough for the jerk senior who was playing basketball. So you're walking across, there's ambling across, and then he pushes you in the direction, he pushed me in the direction I was moving. Am I going to speed up or slow down?
Speed up.
Whether it's positive or negative direction is irrelevant. If I get pushed in the direction I'm moving in, I'm speeding up. So if the force is in the direction I'm moving, I'm going to speed up. All right. The next round of plus minus 0. My position. Displacement. Velocity. Acceleration. There seemed to be a question mark, and the first person went for 0, but I do appreciate taking the chance. Yes, it is 0. Because my velocity is not changing. Now, I'm starting at rest, and now I'm going to move in that direction. So the question I'm going to ask is, when I start moving in that direction, what is my acceleration? I did speed up, but...
It's negative.
You slow down.
All right, I've heard positive and I heard negative. I will tell you it is one of those two.
It'd be negative, wouldn't it? Negative.
Why?
The negative direction that we've established.
I can move in the negative direction and still have positive acceleration, but what would happen then? If I'm moving in the negative direction and the acceleration is positive, what would happen to me?
Slow down.
If I'm starting at 0, how much do I slow down?
You can't slow down any more than that, can you?
Yeah, I don't think so. I've even tried, quantum physics is usually the thing that breaks common sense. And I've even thought, is it possible to start at 0 and then slow down? And I haven't figured out how to do that yet. So we will assume that our sense of that still works. All right. And you cannot go slower than 0. All right, so so I'm at 0, I start moving in the negative direction. It is indeed negative acceleration. Another way of looking at it, my initial velocity is 0. My final velocity is something negative. So my change is negative. Going from 0 to a negative number is a negative change. Time is a positive number. So I'll end up with negative acceleration. And a third way of looking at it, I'm starting here. If I'm going to start moving in that direction, which way would I need to be pushed? In the negative direction. All right, here we go. Moving along, and then I'm coming down to a stop. What's my acceleration as I'm coming to a stop? And again, I've heard the two choices there. I appreciate it's not being 0. All right, so as I'm slowing down, What my velocity, positive or negative? Sorry? You're saying the acceleration is positive? Oh, sorry, I missed it. You were saying opposite, and I was hearing positive. Okay. Yes, it would be opposite. So my velocity is negative. I slow down, acceleration's got to be positive. Slowing down, opposite signs. Or if I'm cruising along in the direction, in order to stop me, something's got to be pushing back on me, slowing me down. Side question: what force slowed me down? Yes. Well, we can do this. I have faith in this group. Position. Displacement. Velocity. Acceleration. Again,
Negative.
as a group, we had at least half of it right. Yes, it is negative. So congrats to those people. Because I was moving in the positive direction, I slowed down, something had to be holding me back. Yes?
So would that gonna be, other than like the force, which was friction or whatever, would it just be, would it just be like a matter of left and right, kind of? Or did you kind of already say that and you're just not getting this?
When you say just a matter of left or right, you mean the acceleration?
Well, I mean, when you're saying that going that way would be positive.
At the very beginning, I said, let's just make to the right positive.
Okay.
You could have just as easily, we could have just said right, left instead of positive, negative. I apologize. Try again.
Well, I mean, I don't have a good question right now.
Oh.
Can I just get back to it when I
Yeah.
figure it out?
Yeah. When you think of it at 2 in the morning, hopefully you don't have my home number to call me.